Welcome to Lesson 1 on Symmetry of Tessellations and Transformations. In this video, we'll have a look at some tessellations. Now, a tessellation is a shape that is repeated and covers an area without overlapping or leaving any gaps. So, for example, we picture this flower shape figure here being repeated over and over to create this tessellation. So we will be looking for any line or rotational symmetry in tessellations in artwork. Tessellations often occur in wall or floor tiles, or in artwork such as paintings or rugs. So they are very common. So I encourage you to look for such patterns at home or in nature. Now for this diagram here, we see that there is no line symmetry, as we cannot fold this over any which way so that it coincides with itself. Now if we use tracing paper, you'll see that it does have rotational symmetry, and in particular, it'll have rotational symmetry of order 2. Now in example 1, we have to determine what type of symmetry, if any, exists in each diagram. And for those that have symmetry, we'll draw in the lines of symmetry and determine the order and angle of rotation. So for this figure here, see that if we were to fold it across this line here, it would coincide with itself. Now I can also fold it across this line as well. So it's another line of symmetry. We can fold it across this line and this line. So that's 4 lines. And then there's 5 lines. Now we can also fold it across right through the middle horizontally here. So that's 6 lines of symmetry. Then there would be another one going up this way. And this way. Another one here. And another one through here. So in total, there are 10 lines of symmetry. Now looking at this shape, you can see that it also has rotational symmetry, and you can use your tracing paper to determine that it has an order of rotational symmetry. Of 10, 1 for every vertex in the shape. Now we also need to find the angle of rotational symmetry. And that is found by dividing 360 degrees by the order. Doing that gives me 36 degrees. Now for B, we'll see that there's no line symmetry here. If you were to fold it down, it would not match with itself, and if you fold it across, it wouldn't either. And it is rectangular, so there wouldn't be any diagonal lines of symmetry. So there's no line symmetry. But there is rotational symmetry. Again, you can use your tracing paper to determine that the order of rotational symmetry is 2. So now the angle is going to be 360 degrees divided by 2, which is 180 degrees. Now for the last one, here we have a beautiful piece of artwork. In fact, it is a square rug. So I'm going to ignore the colors for now, because not all the colors match. So let's pretend this is a black and white picture. So if I were to fold it down the middle, this way and this way, you would see that it would coincide with itself. And because it's square, we can also fold it across each diagonal. So this has 4 lines of symmetry. Now if we rotate this around, you would see that it coincides with itself 4 times. So the order of rotational symmetry is 4. Then to find the angle, I will divide 360 degrees by 4, which is 90 degrees.